Hi, my name is Jeff Vail. I'm the Electromagnetic Compatibility Manager for National Technical Systems located in our Boxborough, Massachusetts facility. Module 1 provides an introductory review of the general requirements for MIL Standard 461F. MIL Standard 461F establishes the verification requirements for the control of EMI of equipment and subsystems procured by the U.S. Department of Defense, or DoD. This covers Army, Navy, and Air Force, as well as Marine Corps procurement groups. Now, verification testing ensures that the equipment will operate as intended when installed in the environment, its platform installation environment. This is covered under susceptibility testing. Basically, what we're trying to do here is ensure that the equipment, once installed in that environment and exposed to its expected electromagnetic environment, will operate as intended without error. In addition to that, we're ensuring that the normal operation of this equipment will not affect the operation of equipment installed nearby it or connected to it in a subsystem configuration. This is where we're measuring the emissions developed by that equipment. Now, the tests are really dependent on a particular installation platform and their corresponding electromagnetic environments. As I mentioned, testing here is involved with a device that's going to be installed in a particular environment. The electromagnetic environment of that platform can vary between a ship, vehicle, submarine, or aircraft. Though the individual test requirements to establish the particular electromagnetic environment may be the same, the actual frequency ranges and amplitudes for these particular tests will vary widely based on the expected electromagnetic environment. Now we'll talk a little bit about some acronyms commonly used throughout the standard. ASW stands for anti-submarine warfare. Now, this is technology used typically on aircraft to be able to detect the presence of submarines within the area. Typically, this equipment is very sensitive to magnetic fields in the electromagnetic environment. There are particular requirements for this type of equipment. BIT, or BIT, stands for built-in test. A built-in test is software used for that particular equipment under test to validate not only that it's operating as intended, but to detect if it becomes vulnerable or susceptible to radiated or conducted susceptibility test environments. COTS stands for commercial off-the-shelf equipment. It's a growing use of COTS equipment, equipment available commercially off the shelf, where integrators will use this equipment to develop a system or platform for the Department of Defense industry. DoD stands for Department of Defense. EMC stands for electromagnetic compatibility. Really, the equipment's ability to be compatible with a known electromagnetic environment. EME stands for electromagnetic environment. EMI-TP stands for an electromagnetic interference test procedure, which is required by MIL Standard 461F. We'll get to that in a minute. EMI-TR stands for an electromagnetic interference test report. These are commonly used to record and present all of the results from a formal EMI test project. EUT stands for equipment under test. This is a common term used throughout the entire document, and it defines the equipment that's being used or certified for a particular platform installation. GFE stands for government furbished equipment. An ALISN is a line impedance stabilization network, as we'll get to further on in this module. RF stands for radio frequency. RMS stands for root mean squared. and TPD stands for Terminal Protection Devices. Now, some general definitions used to describe a particular platform or environment are covered here. Above decks stands for an area on a ship which is not considered to be a below deck environment. Below deck is an area on the ship which is surrounded by a metallic structure or an area which provides significant attenuation to electromagnetic radiation. Such as the metal hull or superstructure of that ship, the pressure of a hull of a submarine, or screen rooms on a non-metallic ship. Now, these, although are on the same platform, will have substantially different electromagnetic environments. So it's important to determine the difference between above decks and below decks platform criteria. In addition to that, we have an internal installation, and this is where equipment located on a platform is totally inside an electromagnetic conductive structure, such as an avionics bay or aluminum skin of an aircraft. And an external installation is equipment location on a platform which is exposed to an electromagnetic environment, or EME, such as an aircraft cockpit, which does not use electrically conductive treatments on the canopy or windscreen, flight line equipment, any support equipment that's attached or used next to an aircraft during pre-flight or post-flight operations, such as uploading or downloading data, maintenance diagnostics, or equipment functional testing. Safety critical is a category of subsystems and equipment whose degraded performance could result in the loss of life. Now finally, the final definition is your test setup boundary. This is used continuously throughout the document, and it defines the test setup boundary of the equipment under test. This includes the entire enclosure or enclosures of the subsystem, and 2 meters of interconnecting cabling exposed to the front edge of this test setup, except for leads, obviously, which are shorter in the actual installation. Now, the standard is structured in 2 major parts. The main body, which contains the interface and verification requirements, and then the appendix. The appendix is a non-contractual portion of the standard, but provides rationale, lessons learned, and details of the requirements and guidance on the interpretation and use of MIL Standard 461F. So there are 2 types of tests covered in MIL Standard 461F. The first type, as we mentioned, is our emissions tests. These measure the electromagnetic energy emitted from the product, either from the enclosure or the enclosure and its individual cabling, interconnecting cabling. This type of testing validates that the equipment will not cause interference or abnormal operation of equipment installed nearby it or connected to it in a full system construction. The second type of test is a susceptibility test. This is where we induce electromagnetic energy onto the equipment, either enclosure or interconnecting cabling, to validate that the equipment will not become or degrade its performance during an event or an application of fields that could be seen in an electromagnetic environment of its installation platform.